Hello everyone, I'm Rob Slater. I'm a co-founder of Redshift Rendering Technologies, and we make the world's first biased, production-ready GPU renderer. We've been around for not very long, and 2016 was another very good year for us. We saw growing popularity amongst freelancers and wider adoption amongst high-profile film and TV production studios. So last year, Digital Domain became a customer. They have a great reputation for producing fantastic work, and we're really excited to see what they do with Redshift. And Blizzard actually were the first customer of ours to push Redshift really hard with really heavy scene assets. The end result was the entire episodic content for their cinematics for their popular Overwatch game. We think these cinematics are really, truly gorgeous, and in fact, they actually got quite a lot of attention on our booth at SIGGRAPH last year. And you can check them out on YouTube if you're interested. And also, Polygon Pictures became our largest customer in Japan. They have a reputation for doing fantastic cartoons and animated series, and they chose Redshift to render Amazon's new Lost in Oz series. They were very happy with the results, and in fact it won 3 Emmys very recently. And also we brought on board Cosa VFX late last year. They do a TV series like Westworld, Marvel's Agents of S.H.I.E.L.D. and Gotham. Now I'm actually very thrilled to be working with these guys because I'm a fan of their shows. And we're all very excited about our future with Cosa VFX. And also in the pipeline, we're working with some more high-profile studios. There are some TV series coming out and some movies that we can't talk about today, but maybe we'll be able to talk about them in our talk next year. Okay, so one of the things that people have been asking for as the more awareness of Redshift has grown is that they want more like integrations into the DCCs other than the Autodesk Big Three, like Maya and 3D Studio Max and Softimage. So with that, we actually brought out a Houdini plugin earlier this year in January. That proved like a very popular. It was a very smooth plugin process. And hot on the heels of that is a Cinema 4D plugin. This has just come out very recently. It's still technically in alpha, even though it's being used in some productions. And we actually wanted to keep this in alpha for as long as possible because we wanted it to be a really strong integration. And also, late last year, we started our Katana plugin. This is in a closed alpha. It's going very smoothly. It's being tested by some large studios right now, and hopefully within the next couple of months, we'll be able to release it to the public. So within DCCs in general, we had like some requests for the Mac OS support. And now naturally, because like Cinema 4D is very popular amongst Mac artists, we like prioritized for this so that we could get Redshift for Mac OS out. And this actually came out in spring. And I think it's actually, that was alpha. And now, about a week ago, we released it to the public for you guys to try. And also 2016 saw some more third-party support with Redshift. So Peregrine Labs bought Yeti with Redshift. This is something that people have been asking for quite some time, so finally it's out there. We're very pleased with that. And also we got a request to support the Golem crowd generation plugin. Now this is popular amongst like TV, high epic TV shows and movies. Actually, like integrating with Golem involved adding new technology in Redshift. We actually wanted to prioritize for this because we felt that this would bring Redshift closer to the feature parity of CPU renderers. We're going to talk a little bit about that technology later. And of course, with growing popularity, with more questions and requests for more tutorials. So we hired some artists that were familiar with Redshift to produce some quality tutorials, and we released these on YouTube a few months ago. So one of the things that we try to do with Redshift throughout the year is, as well as adding new features or improving things, we'd like to make sure that the performance is up to speed because that is our selling point. Redshift is fast. So last year we brought out Redshift 2.0. And with that we brought like a new Redshift material which featured like multiple BRDFs like Beckman and GGX, and also a physically correct Fresnel for rough reflections. Adding these new features actually took a little bit of a hit on shader performance, so this is something that we wanted to look at and see if we could fix. So one of the challenges that we have when programming for a GPU is that GPUs actually have limited resources. And this means that you can write very complicated code which will still run, but unfortunately will run significantly slower than it should do. So actually so we went into the code and we basically rearranged it and found some like bits that were not very smart and actually gained back about 10% of the performance on the GPU. And I don't know if any of you guys, probably not, remember our first talk at GTC back in 2015, but we announced proudly that we were using function pointers to execute the shader nodes of the material shader graph. Now, this was a very convenient, very flexible solution for us, but unfortunately, it did come with an overhead that was not very good, actually. So we decided to scrap function pointers and switch to giant switch statements instead. Now, if any of you out there are programmers, you'll know that a giant switch statement's a pretty ugly looking thing, but thankfully it made the rendering actually render faster, so we stuck with that. And also we had some long-term goals for optimizing how the shaders communicate with the ray tracer. This actually gave us the biggest win overall, about 40% performance improvement. So with all these things that I've just mentioned here, we actually got almost 2 times faster rendering over Redshift 2.0. Another criticism that we've had from Redshift is that when you would have like many AOVs in flight while rendering the beauty, is that could actually be quite slow. Now we use the GPU to do all the heavy lifting like shading, tracing and texturing, but we use the CPU to post-process AOVs. So we try to do this smartly. We use all the multi-threading capabilities, multi-core capabilities of CPUs, but it was not as efficient as we would like. And we actually found that there were some pretty serious bottlenecks between the GPU and the CPU, like one was waiting for the other and vice versa. So we decided to go in and dig deep, eliminate all those bottlenecks so that the AOV processing can run more in parallel with the GPU rendering. And that actually gave us a 2 times speed up. And also from some of our large customers that have very large proxy files, we got some complaints that they were very slow, especially if they were being transferred over a network. So we decided to actually try and improve our file access system in general by using a caching system. This gave us like a good performance benefit. And smarter, do compression. So this means that you can compress these giant proxy files, transfer them over the network, which makes it, way faster. And we actually got like a huge win with this, about 10 to 100 times faster for our large proxy file processing. And also very recently, we actually found there were some bugs in Redshift, especially when if you had like shadow rays that were tracing transparent objects, we found that the actual texture caching system was not being used very efficiently there. So we actually managed to improve that and fix that bug, which came back quite a bit of performance. And we're also doing some research right now to improve importance sampling overall, especially for blended materials. Now this is a bit of R&D, and we think that we can get blended materials running about 3 to 4 times faster in the future, so watch this space. So recently we brought out Redshift 2.5. This basically supersedes Redshift 2.0, and it's going to bring new features and general visual improvements. So the first improvement is with noise detection. So it's been, people have complained in the past that our unified sampling does not clean the frame very well, but when you have like very bright areas and very dark areas. So basically, the bright areas would clean up really nicely, very quickly, but the dark areas would actually stay very noisy. And now, how artists would fix this is that they would basically have to either reduce the variance threshold, or they would have to increase the number of samples, and sometimes with really heavy scenes, they would have to do both. And what this would mean is that, yes, the dark noise would clean up, but the frame would render significantly slower, so that's something that we wanted to fix. So with Redshift 2.5, we've introduced an improved variance metric. Now what this means is that you're going to get like a more balanced noise reduction across the entire frame for both bright pixels and dark pixels. And we want to obviously get this to be faster as well. So just to give an example, we've got like a very simple dome-lit scene here. You can see the bright areas cleaned up very, very nicely, but the dark areas here are very noisy still. Now this is using 2.0 and using the default variance metric of 0.01. This was running about 19 seconds. So to try and clean up that noise, we reduced the threshold to 0.03. 003. And as you can see, it got like a nice and clean, but unfortunately, it actually rendered twice as slow, which of course is unacceptable. And the Redshift 2.5, with the new importance metric, we're using back to the default threshold of 0.01. And now you can see that the noise is generally kind of like even all over the entire frame, and the dark areas are nice and clean too. And more importantly, this renders back now at 20 seconds. So, fireflies. Everybody hates them. All ray tracers suffer from fireflies, Redshift included. Now, fireflies is when you have like a very rough surface reflecting something that's very glossy that can see a very bright light or very light incandescent object. Now, due to like low probability, you're going to get these nasty fireflies. So, as you can see here, there's a nice, well, actually it's not nice. This is horrible programmer art. It's mine. But even more horrible in there are those nasty white dots. Those are fireflies. So how do we clean up fireflies? So in Redshift 2.0 and prior to that, our only solution was to have like a very aggressive secondary ray intensity clamp, which means anything that's like super bright would get brought down to like a lower intensity. And as you can see, it cleaned up the fireflies quite nicely, but you actually lose a lot of the detail, a lot of the vibrancy has gone there. So this is something we wanted to fix. So in 2.5, we've added a roughness clamp as well on top of the glossiness, on top of the intensity clamp. And what this has given us now is that we get back the reflections in the scene and some of that vibrancy, but we've also cleaned up the noise as well. So this actually rendered with the same number of samples as that, and you're getting like much better results. I have to say, to get that kind of noise, cleaning it with this, using 2.0, you'd have to use about 60,000 samples, which of course is ridiculous, right? So less energy lost, fewer samples required means faster rendering and better looking results. So one of the new features that we added for 2.5 was some material flexibility features. So as I mentioned earlier, we were integrated with the Golem plugin. Now one of the things that this plugin required was per object user data. So this is basically where you can store any kind of data, any kind of attribute on an object, like on a mesh, like scalars, colors, vectors, integers, that kind of thing. And you can then use them in the shaders to actually get material variations without actually having to have different materials, which can be like very cumbersome to set up. Now to facilitate this, we've added some new shader nodes. So we have some shader nodes to actually read that object data, and also a shader switch node. Now what this shader switch node gives you is the ability to have different shader graphs for different switch values, which you can then read from the objects. And that means that you can, say, use the same material for, like, say, different textures, for example. You might have like different textures for different objects, like a smiley face and a sad face or something like that. So this can do that like really efficiently. It's easy to use, and there are about 10 inputs on it, but if you want to be more like go crazy and have a more complex shader graph, you can actually chain these to be more flexible. One of the things that was very important to us when we added this was that it was very efficient too. We didn't want to actually burden regular shading by adding this new technology, and thankfully we did that. Okay, another feature, so particles. So we've always supported mesh instanced particles, and these are very flexible, they look really good, but they actually come with like an overhead of using more memory than we would like. And as I mentioned before, like with user data, we also have per point particle data as well. That means you can like vary the color of particles, and this data cannot go out of core. So this was a problem. So we added some simple particle primitives that are built into the ray tracer itself. So initially this is going to be like sphere primitives, and these are perfect for like very fine-grained effects like sand or dust or like spray, that kind of thing. These things can render incredibly fast, they're very lightweight, so you can get like hundreds of millions of these particle primitives without actually using a lot of memory. And best of all, they can actually go out of core as well, which mesh instances couldn't do. All right, automatic memory management is finally here. I'm not lying. So we actually announced this back last year at SIGGRAPH. This was going to be coming out of Redshift 2.0, but we decided to put this feature on hold so that we could like concentrate on improving 2.0 in general and adding new features for 2.5. Anyway, what this feature gives you is the ability to get Redshift to actually tune the memory budget between textures, rays, and geometry to get the best possible performance. So a very good situation for this is like where you've got like one box, but you've got two different GPUs in it. So you might have like a Titan with 12 gigs and a Quadro with 24 gigs, and then you want, you can't actually go in there and manually like tune how you're going to use that memory for both those cards. It's not easy. So Redshift will do that for you with automatic memory management to get the best performance. And also very recently, about like 2 weeks ago, we had a trace set. Now this is like power users. This allows you to be able to choose what a surface can see either through reflections or refractions. And now this technology is actually deep inside the ray tracer, so it was very important that this was fast. We didn't want the ray tracer to actually get slower by adding this feature, because sometimes, more flexibility means worse performance. But we actually found a way to actually have no performance impact, so we're very pleased with that. So, trace sets. Okay. So Redshift has been criticized in the past as being very, very fast at doing final frame rendering, but kind of sluggish when it came to like interactivity, like IPR mode or scrubbing shader balls, that kind of thing. So this is something that was very important for us to fix for 2.5. So we worked very hard on this. So we actually want to get like a real-time feel for like playing with Redshift and looking at things in IPR. Now, we're like ex-video game programmers at Redshift, so we don't use real-time lightly. To us it means 30 to 60 frames a second, which of course is silly for like final frame rendering. But instead, this feels like real-time rendering. And with this, we actually brought out a Redshift viewport. Now, currently this is available on 3D Studio Max and C4D. It's going to be in Maya and Houdini very soon as well. And now what this gives you is the ability to, first and foremost, get the data very quickly from Redshift to the viewport so you can see, which of course is crucial for interactive rendering. And also we're adding some features like render a snapshot history so you can compare frames. And also like AOVs has been something that people have been asking for as well. They want to be able to see AOVs in the frame buffer without actually having to like go and look at them in Nuke. We're also considering adding like effects like depth of field, so you can basically take like your mouse and like pick a point on the screen, and then Redshift will automatically adjust the camera for you to get that depth of field effect. And then maybe we're going to add some effects like bloom and things like that as well later, if enough people ask for it. We've just added the Redshift benchmark tool as well, so this means you can take a proxy scene file and then like render it and get some nice easy to read stats back, so you can actually compare the relative merits of different graphics cards. Now initially this is going to be like the Redshift command line. There's no GUI here, but enough people ask for it, then we'll add a user interface for it too. Okay, coming up, custom AOVs. These are very powerful things. These are just around the corner, probably I would say about a month away. So what this gives you is the ability to be able to store any data from within a shader graph at any point to any file. And so with that, we're going to be adding 2 new shader nodes to Redshift. We're going to be adding a node to actually take the data and store it. And we're also going to be adding a node to actually like allow data to pass through without affecting the beauty if you want to store it later. And we'll talk a little bit about the benefits of that in a second. So one powerful thing of having custom AOVs is that you can do like true multi-layer material compositing in post. This was something you could not do with 2.0, and now you can do that with custom AOVs. And also, so we're going to be able to do like very efficient AOV pass rendering. So an example of this is that like an artist might come to us and say, "Hey, I want to be able to like generate like an AO AOV, like a full screen like AO. How do I do that?" And unfortunately, there was no easy way of doing it. So we'd have to say you have to go and like make a new pass, replace all the materials with an AO material, and then away you go. So this is a very cumbersome thing to do, and it's also very slow because you have to render the scene twice. So with the custom AOV tech that we're going to be adding, this is not going to be a problem anymore. So you're going to be able to define any kind of say override for like an AOV, like AO for example, and it's going to actually generate it concurrently with the beauty. So of course, easier to use and faster as well. Just after that, we're going to be adding per light AOVs. This is something that power users have been asking for. We're very excited about adding this feature. And also some puzzle map, multi-mat optimizations as well. Like right now, this can be pretty very slow because it renders things in multiple passes. So we're going to be reworking this so it can render more things concurrently, so you'll get your puzzle mats out much quicker. And also Alembic procedural support is coming very soon. So this means you can take like raw Alembic data without actually having to unpack it in the actual DCC and transfer it around, which can be like quite a long process. You can take this lightweight files and let Redshift take that data itself when it needs it, which of course means scene extraction is going to be faster too, and scene's going to be more lightweight. Okay, so coming in the future, the much promised shader SDK. Some of the larger customers have been asking for this for some time. I know a lot of people from Blizzard have been asking for it. We hope to get something to you out there probably by the end of the year to test in alpha. There's a lot of thinking that has to go behind this, but we want you guys to be able to write your own procedural shaders instead of asking me to write them for you. So, this is a priority for us to get this ready for you guys. Toon shading is something that's just around the corner as well. We've got some very good ideas about how to do this. We want to be able to get all the kind of like features that you want from toon shading with very good performance as well. And ray trace subsurface scattering, another very important thing. So there are two reasons why this is important. Firstly, with point-based, you can't get that fine detail around noses and stuff like that. You can get that with ray traced. And the other thing is that our progressive rendering does not support subsurface scattering, but with ray trace solution it will do. Now we're actually working on this right now. We're working on technology to be able to get any kind of subsurface scattering profile, including the old ones and new ones that we've not thought about yet, rendering very fast in the ray tracer. So that's something that we're working on, and the numbers are very encouraging. And distributed remote rendering is coming soon as well. And we're also going to be adding support for barn door area lighting, like directional lighting, where you can like focus an area light's direction. XGen instances as well as just around the corner, as well as Maya curve support. Oh, free educational licenses are coming this September, so you students out there, just get in touch. We'll give you some free licenses and you can play with Redshift. Okay, that's it for me. Please contact us for information if you have any, or come and visit us at our booth 231 if you want any questions.